Good afternoon. Thanks very much for the introduction. I'll start with just three opening comments. Firstly, congratulations to EPA on this report. I was involved in a workshop that seems a long time ago, and I've had some email contact with some of the people working on the energy chapter, but I have some small appreciation of the amount of work that goes into something like this, so a really hearty congratulations to EPA. My own direct involvement was mostly with Brian, Andy and Paul, but looking at the author list and the list of people involved, it's a phenomenal output, it's a phenomenal resource and something EPA should be very proud of. So the chapter I was involved in was chapter 12, Environment and Energy. And interestingly, the title of the talk is Transitioning Our Energy Systems. And listening to the presentation on land, I could see some parallels. That's the second point I wanted to make as introductory comments. And namely, it was the four messages. The way you synopsize the four messages, you could replace land and stick in energy in terms of energy is having negative impact on our environment. We can fix it. We know what to do. It is challenging, and it's a whole of societal challenge. So it's kind of interesting to see those parallels. The third introductory comment is what I mean by energy systems, because some people associate, when they think of energy systems, they think of maybe the electricity grid. And for me, that's part of the energy system, but it's not the whole story, because our heating systems and our transportation systems those three systems together are where we use energy in different forms and for different purposes. And actually, electricity represents just a fifth of our energy use. Transport and heat dominate. Now, I know transportation is dealt with separately, and that's correct. But the energy impact of transportation is very significant, and that's why I would consider the energy use in transport as part of the energy system. Also, the energy system is all the way from the fundamental sources of energy, be it crude oil, natural gas, wind, solar energy, right through to the systems that convert those raw forms of energy into useful energy, be it in a power station delivering, which is required to deliver electricity to meet our needs for electricity use, be it in an oil refinery and then subsequently oil that's trucked across the roads of Ireland to bring it to petrol stations, diesel pumps, and also, of course, home heating, kerosene, and the natural gas system, which is a piped system where we import most of our natural gas, but we do have some indigenous gas still coming from the Corrib gas field. And natural gas we use mostly for electricity generation, but also for heating. So all of that combined is what I refer to as the energy system. And so in terms of transitioning the energy system, I'll start with the key messages, but as I say, you'll see a common thread in terms of what we heard on land. I wanted to start with some good news. So the energy transition is well underway. That's internationally, but I'm talking here about Ireland, and I'll come back to that shortly in terms of the evidence for that and what I mean. The second thing is that we do know more or less what we need to achieve in the short term. On the supply side, we need to displace fossil fuels with renewable energy, but we have wind energy technology, we have solar energy technology. These are commercially available. They're well embedded in our system. We're familiar with them. There are systems challenges in integrating them, and Ireland is leading the world in that regard. But we know the technologies we need in the context of the short term. Also, for the long term, we have this huge opportunity for offshore wind, and it's kind of interesting the way these things develop over time through innovation, and that's not just the technology innovation, but market penetration, and across the entire system, innovation through to policy and implementation and development. But what you can see very clearly is the cost reductions that happened in wind energy during the 1990s and noughties subsequently happened with solar PV. And this is why solar is a key prospect for Ireland now, and it's a key technology that's contributing increasingly to our electricity supply mix. Whereas a number of years ago, solar would have been very expensive and not seen as suitable in an Irish context. Similarly, we're seeing great strides in offshore wind energy with cost reductions there. That's a work in progress, and the cost reductions are still coming down. But we have a huge opportunity in terms of offshore wind, and that's expected in an Irish context in particular to be key to our future energy supply mix. So that's some of the good news. In terms of that, and that's on the supply side, we also have technologies in terms of how to make use of the new forms of energy in this energy transition. So rather than using petrol and diesel in our cars, rather than using kerosene or natural gas for our heating system, the electrification of heat and transport is also something that's come on leaps and bounds. However, an electrification of heat and transport means we're switching from one part of the energy system, from the traditional transport and heating systems that are dominated by fossil fuels, towards electricity. So that means more electricity usage. But the efficiency gains and the fact that it means we can make more use out of wind and solar is a positive. However, there are other trends in electricity demand growth that are worrying. And particularly in an Irish context now, we've seen significant growth in data centres, for example, where it's pushing up the demand for electricity at a significant pace. And that's raising challenges in terms of both the impact energy is having on emissions, but also in terms of our power system. And again, I'll come back to that, because it's almost like we're growing the electricity use while trying to transform our electricity system at the same time. It would be a very different scenario if we were looking at the growth in data centres happening, say, 10 years from now, where we had a much different power system, but it's challenging at the moment. There are other areas where it's challenging as well, and one example is in car transport, where we can see and track, and we are doing the growth of electric vehicles in our fleet, a very positive development. But sometimes there can be blind spots, like the growth of SUVs that's happening in parallel, or the growth of transport energy use associated with private cars. So blind spots is another thing that we need to be very mindful of. A key challenge, and this is one of the biggest challenges we face actually in the energy transition, is we have the technologies, but we're talking about fundamentally a change in infrastructure, be it wind farms, be it solar energy farms, be it the electricity network. What do we do with the gas network? Can we transition it to renewable gas and to hydrogen, or is it redundant? So questions around infrastructure are really key to actually enabling us to achieve the goals of the energy transition. Not everything can be readily electrified. Long distance air travel, maritime travel, long distance road haulage. Fuels are still going to be needed to meet some of our energy needs. But we do have this opportunity, again, an emerging and new opportunity in terms of low or zero carbon fuels, be it biogas or green hydrogen. So using some of the wind energy to generate hydrogen, to use that as a fuel. And we also really need to, and this is a really tricky one, the negative emissions technologies are going to be needed to kind of draw carbon dioxide out of the atmosphere. The challenge, there's a real challenge around the narrative of that, because the narrative of needing negative emissions technologies can be used to sustain the fossil fuel infrastructure and fossil fuel industries. So it's a really tricky point of discussion that we do need negative emissions technologies, but we need to accelerate the transition away from fossil fuels to renewables at the same time. And those aspects can be complementary or they can compete with each other. And finally, and this goes back to the people piece we saw in the land, we're talking about a societal challenge here, because if it's around infrastructure, we need to change the planning system, which involves engagement with society. We need to build out new infrastructure, which involves engagement with society. We need to transition from these end-use appliances, retrofitting buildings, the electric vehicles, the heat pumps, and retrofitting our homes. All of those things are household decisions or business decisions. So we're talking about a whole of society challenge. There's economic parts of this, and I'll come back to that in terms of how we subsidize certain things, and governance dimensions. I mean, the planning bill or the planning act is now in place, and there's concerns around, is that kind of overstepping in terms of democracy, or is it going to be an enabler to accelerate the building of infrastructure? These are challenging societal questions. So there's some of the key messages, and I'll come back to them at the end, but I'll just go through some snippets to kind of point to each of these on the way. So firstly, when I say the energy transition is well underway, what do I mean? Well, this is a graphic that's in the report, and it shows the trend in terms of fossil fuel use in Ireland going back to 1980. And the red line or orange line on the top is total fossil fuel usage. And if we look at the total fossil fuel usage in Ireland, what we see is that our fossil fuel usage peaked in 2007. So our fossil fuel usage in Ireland peaked, 17 years ago. And that's a phenomenal, often hidden part of the narrative in terms of the impact on energy and the environment and Ireland's story. Now, of course, it needs to decelerate faster. The trajectory here needs to accelerate downwards, but you don't often hear that comment been made, or that piece of information being discussed, the fact that in 2007, that's when we peaked. So we're currently back at 1997 levels, roughly. 1997 is kind of, at the early stages of the Celtic Tiger period. So our economy has grown significantly. Our population has grown significantly since then. Both of those things, of course, put pressure on energy use. And in a normal business as usual scenario prior to that, that would have meant we'd be in a very different scenario. So some of the successes that we've achieved in terms of energy efficiency, in terms of renewable energy, are kind of masked. But it's very clear when you see that kind of reduction since then that we've made some great progress. Not enough, but we've made some great progress. If we look at the individual fuels, we get a story of what's happened in Ireland over this period since 1980. Our usage of peat peaked in 1985. Our usage of coal peaked in 1989. And if you look at the gas, is a trickier one. I mean, it peaked in 2010, but it's kind of fairly much flatlined. But part of the reason for that is we've used gas to displace some of the coal we were using in electricity generation. We've used gas to displace some of the oil that we've been using for heating. So there are some parts of the transition where we get cleaner fossil fuels displacing dirtier fossil fuels. And essentially, the important thing to watch with gas is that, again, it decreases rather than staying stable or increases. And with oil, that peaked in, I think it was 2005, we had the peak in oil use. Now, of course, you could take pieces of this, look at the Celtic Tiger, look at the economic crash, look at COVID, all of that. But this trace since 1980, I think, tells an interesting story. And it's a positive story in terms of some of the policies that we've implemented and some of the successes that we've achieved in the energy transition. So where are we now? Well, we still have an energy system, an energy supply mix that's too dominated by fossil fuels. So renewable energy just represents 14% of our energy in Ireland. Again, we've had more successes in electricity than elsewhere in terms of renewables. If you look at renewables as a share of electricity use, you'd be up at 40%. But this is total energy use, so it's including the energy used for heating and transport. And as we can see, our system is dominated by oil. We have an oil-based energy system. Half of our energy is from oil. 30% nearly from natural gas. And then you can see the dwindling amounts of solid fuels. And the solid fuels have gone down even further. This is data from 2022. So 2023 shows even diminished use of solid fuels. In terms of the environmental impacts of these energy trends, again, this is a snapshot from a single year. And there tends to be a focus in environmental discussions on energy linked to climate change for obvious reasons in terms of the damaging impact energy, particularly fossil fuels, have on greenhouse gas emissions. And if you look on the left-hand side, you can see the share of energy use from different fuels. But they have an interestingly different perspective, or different impact, rather, for some of the different pollutants. With CO2, there is a linear relationship between energy used and CO2 emissions. The emission factor for each of the fuels is different, so coal and peat are worse than oil, which is worse than natural gas. But you can see broadly with CO2, there's some level of alignment apart from, as I say, the emission factors varying a bit. But it gets much different when we start looking at things like PM, particulate matter. And here, solid fuels dominate, even though they represent just 8% of energy use. So some fuels are really bad at some types of pollution compared to other fuels. And of course, the challenge with particulate matter is it causes deaths in terms of respiratory, not just deaths, illnesses associated with that air pollution. And then you can see as well for NOx emissions, that's dominated by the oil use in particular. And in terms of some of the sometimes hidden aspects to this story of what we're actually doing to make changes in energy, it's very interesting to look at the subsidies that are given for fossil fuels and the subsidies that are given for renewables. And this is a comparison across the European Union. And you can see the left-hand side, the bluer areas are subsidies for fossil fuels, the greener shaded areas are for renewables. And the solid bars then represent whatever the net is. Is it a net fossil fuel subsidy, surplus in fossil fuel subsidy, or renewables? And what's striking is where Ireland is positioned. We're second, but we're the second most subsidising, if you like, in terms of surplus as a percentage of fossil fuels subsidies over renewables. As I mentioned, we do have a pathway. We do know what we need to achieve. And I want to congratulate the EPA on another significant report. This is earlier this year, the Ireland's first climate change assessment. And we were very fortunate in the Environment Energy chapter to be able to draw on the analysis that was done then, particularly Volume 2, which focuses on climate neutrality. Now, it covers not just energy, also agriculture and land use. But the energy piece is where we have actually more clarity on what the pathway is to a net zero energy system. And some of the things that I mentioned come out there in terms of the technology choices, the electrification, the efficiency, but also the fact that it's a whole of society challenge, and the solution requires whole of society approaches in terms of getting the policies right, getting the strategies implemented, and the societal buy-in, mobilizing society around these elements of the pathway. So as I mentioned, a clear part of the short-term solution, this is just to reiterate it, is in terms of wind and solar. We're underway, but it's not happening as there are blockages in terms of grid, in terms of planning, in terms of market, supply chain. There are a number of challenges, but we know what we need to be doing in terms of the short-term supply mix. And in the longer term, we have offshore wind as a key component in our energy supply mix. As I mentioned, on the end-use side, we know we need to transition towards a mostly electric energy end-use system in terms of transport and heating, are what's shown here, just to give two examples. As I mentioned, there are parts of the energy system that are better served with fuels, but rather than those being fossil fuels, they should be renewable fuels, be it gaseous biomethane, be it hydrogen, be it a derivative fuel from hydrogen, such as green methanol. There's a number of renewable fuel options for those sectors. And that's a part that still needs to be, we still need to grapple with choosing and putting in place proper policies and implementation pathways for each of those. We do have a hydrogen strategy, for example, which is a great piece of the policy mix, but we don't have a target for 2050. So the finishing off the story of some of those is necessary. And as I mentioned, we need these negative emission technologies. This is one example, which is bioenergy coupled with carbon capture and storage. So when the trees or the plants or the biomass is growing, it's absorbing carbon dioxide. You release that carbon dioxide when the biomass is combusted, but then you capture it. So the net effect is negative emissions. And of course, that complements then other nature-based solutions for also achieving negative emissions. And finally then, as I mentioned, while the technology part of this is relatively simple, it's not that it's not challenging, but it's relatively simple compared with the societal, the whole of societal approach, getting that right in a timely way. So that's the messages back up. Sorry, I've gone over time. Thank you very much for your attention.